So what is the strongest black PLA out there? You might not realize it, but many different brands have a lot of different variations in how they actually make black PLA. And in this video, we're going to go through and print a whole mess of dog bones in order to test which one of them is actually the strongest when 3D printed. So first of all, let's talk about the test conditions of this video. We use a standard 4mm by 13mm cross-section dog bone. This is put into our tensile testing rig, which is able to pull until the thing breaks. All of these samples are printed vertically. This allows the layer lines to be crosswise around here. Whenever a part is printed down flat, it has about 90% of whatever the default material was for that part. So the flat test isn't really that useful because 3D printing adheres by the layer lines. That is the weakest axis. So the weakest axis is where you will have the most failure. Therefore, we test with printing vertically. In the future, we will probably do tests of them laying flat, but for this video, all of them are printed vertically. Right here, we wanted to test all of the black PLAs. So we tried to get them from as many different brands and with as many different variations as we could reasonably get a hold of. So we got standard Overture black PLA. We got Polymaker PLA Pro, which is a matte black, Polylite PLA, and Tangled PLA. Tangled PLA serves effectively as the control for all of these because we know that Tangled PLA is 4043 NGO material. It is a virgin material, it has been around for a long time, and it has a very clear data sheet of how it actually behaves and operates. So we have a good reference that that material is clean and clear. It has a standard carbon black colorant inside of it, and we know what those proportions are. So we're able to compare against the other materials which generally just have the brand name. And even though they say PLA, they may have properties that are very different from PLA. And based on their overall mix, we can infer what some of the other properties like colorant may be within those materials. So with that, let's go ahead and just dive right into the tests. So let's go ahead and start with Tangled PLA because it's the control group. So let's just do a quick refresher of what it's able to take. After popping Tangled 10 times, we get an average peak force that's able to maintain of 1,627 newtons, which is about 250 pounds or so, which is really impressive for a dog bone to hold up. I mean, to have a whole guy hanging from this thing is pretty darn good for PLA, which is pretty darn brittle. That comes out to an average stress of about 31.3 megapascals, which is where we expect it to be. And that's based off of all of our previous tests and has continued to hang around there. Like I say, Tangled PLA is pure resin. We don't add any other additives to it at all. It is just clean as it is, which is not necessarily a good thing. The additives that other manufacturers put into the filament can give it new and different properties that can improve retraction or flow or overall usability and durability. There's many things that those additives can do. So even though we're testing strength in this, it's not the only metric, but it is the metric that we are testing in this video. The next test we did was Overture PLA. Pop that a few times, and then we end up with an average force that it was able to withstand of 1,570 newtons, which is only slightly lower than the standard PLA, which is great news because when you have a manufacturer tell you we made PLA, you expect it to be the PLA. NGO 4043 was effectively the original PLA. There was another variant from Corbion, which was kind of, not a knockoff, but a similar formulation and similar properties. NGO 4043 is very certainly what most manufacturers mean when they say PLA. But it gets hairier when you start saying PLA Plus and Pro PLA. But that is a conversation for another video. But ultimately, the Overture PLA appears to be just that, black PLA, with potentially a little bit more black colorant than what we use. We generally use a fairly low concentration of black because it spreads so well. But in order to get a deeper black, and just to be certain that there's no possibility for variation, they may overload it with carbon black, which could potentially be what's causing the weakness. Though at the same time, in the context of all of these tests, that variation of stress between 30 and 31 is so small that it could just be attributable to testing error. So for the purposes of this, we're going to say that Overture PLA and Slant 3D Tangled PLA are just about the same from a strength standpoint. Next, we move on to Polymaker PLA Pro. Now this is PLA Pro, which adds in a little bit of a wrinkle because we don't know if it's actually truly PLA, though at the same time, we don't know if regular PLA is actually PLA. But it was the only one that we could get that was matte, and when testing blacks, we want to test how matte affects it. And historically, matte sometimes creates some weirdness. So let's go ahead and pop the tests on these. Ooh, doggy, that was a little bit worse. With the Polyterra Matte Black, we ended up with a maximum force of 756 average across all the tests. And it was actually a pretty tight test. There was not a lot of variation. Sometimes we see a big old widespread of data with these tests. There was not a very widespread of this. It went over about 100 newtons back and forth, which is right within what we would expect from the variation of just 3D printing in general. So there are two factors that could be contributing to this. Again, PLA Pro is generally considered to be a softer material. It is more durable, but it's softer, and therefore it is able to withstand less force than PLA, which is a very brittle material, but also very strong. It's very much like standing on top of a wine glass. You can stand on a wine glass and it'll hold you, but as soon as it bends, it's going to snap and break. Whereas materials like PLA Pro are generally more durable to where they can take some flexibility in bending, but they are weaker overall, like standing on top of a wine glass made of rubber. But there is another wrinkle in this, and it is the matte colorant. And we have seen that matte colorant in other tests have created weaker parts. So there's something about creating the matte texture that creates a weaker part, and mainly it is due to particle size. In order to get that matte finish, in order to disperse light in that way, you kind of have to throw sand into the part. And to do that, you throw sand into the part, which means that you no longer have as much plastic adhering across the layer lines as you might have with pure carbon black, which is a very small particle for colorant and doesn't affect the part as much. Finally, our last test is Polymaker Polylite PLA. Again, it is standard PLA. We would expect it to be about the same as regular PLA. Once we pop these few tests, we come out with a mean force of 1342 newtons and a stress of about 26. This is lower. This is demonstrably lower. The Polylite PLA, again, very likely has additives in it. This does not mean that it's an inferior product. Again, the Polylite PLA, even when we look at the PLA itself, is less brittle than a pure driven PLA like ours. We can just see that by manipulating it. Polymaker puts other additives into their stuff, which doesn't really necessarily change what the material is, but it does change its properties. They do this to improve extrusion, which means that Polylite very often can be printed at higher speeds or at lower temperatures than typical type of PLA. So like Tangled PLA has to be printed as high as 235 because it hasn't been reprocessed and had a bunch of additives thrown into it. Whereas Polylite has a much lower recommended print temperature of 180 to like 200, 210. So they are adding other stuff to this, which makes it weaker within the context of layer adhesion, but can make it easier to process. And we have to remember that all of these materials, especially Polymaker is a material company that does focus on how to design better materials, but for use in consumer 3D printing, where ease of use is the most important, not necessarily material properties. So hopefully this has helped inform you a little bit about the different black PLAs out there. They're not all created equal. How different manufacturers make them makes a difference. And you can use the specs of these materials in order to evaluate how they compare to actually true driven material. So you can question, can I use the actual data sheet of that material, or do I need to just run a bunch of tests to find out if that material is actually true or not? And that's what we hope to do with this whole Tangled testing channel in general, is show how 3D printed parts behave once they've been 3D printed and put under stress in very controlled circumstances. So if you want to continue seeing these types of videos, please hit subscribe and let us know what other tests you'd like us to see in future. There are millions of them to do. We're cranking away at them as fast as we can. We're keeping them controlled at the beginning, but we are adding them to the list and we will get to them eventually. Have a great day, everybody.